So glad to be here today. Thank you all for coming. And Secretary Granholm, thank you for that really exciting announcement of the Hydrogen Energy Earthshot. I cannot think of a more energizing way, no pun intended, to kick off this year's Hydrogen Program Annual Merit Review. First, I'd like to thank all of you that are joining us today, including all the principal investigators showcasing your hard work, as well as all of you volunteering to serve as reviewers. Your participation in this merit review process is really invaluable. For those of you who are not as familiar with the Office of Energy Efficiency and Renewable Energy, or EERE, this is the office where the Hydrogen and Fuel Cells Technologies Office resides. And we work across multiple sectors, across renewable power, sustainable transportation, and energy efficiency. Now, I am sure that you all know Dr. Sunita Satyapal, who leads the Hydrogen and Fuel Cells Tech Office. Dr. Satyapal will provide a deep dive on the work that we do in the next session. So I'll just be brief and say that one of EERE's flagship initiatives is H2 at Scale, which works to enable large-scale, affordable hydrogen production, storage, and utilization across different sectors in the economy. The key to H2 at Scale is that it can integrate different sectors and uses that can benefit from hydrogen. It helps scale up the volume of hydrogen used, and it reduces cost for the end users. Hydrogen really opens so many doors, from tackling hard to decarbonize sectors, increasing resilience and affordability, making our natural gas system cleaner, and helping us transition to a net zero economy, a net zero emissions economy with good paying jobs. This is just one piece of the puzzle, but we're going to need an all hands on deck effort to make the necessary giant leaps to reduce costs that enable at scale use of clean hydrogen. Collaboration is absolutely essential. So that's why I'm really excited to kick off this panel next, and to be joined by my DOE colleagues overseeing hydrogen related work. Dr. Jennifer Wilcox, Acting Assistant Secretary and Principal Deputy Assistant Secretary in the Office of Fossil Energy and Carbon Management. Dr. Catherine Hupp, Katie, Acting Assistant Secretary and Principal Deputy Assistant Secretary in the Office of Nuclear Energy. And Dr. Stephen Binkley, Acting Director and Principal Deputy Director, Office of Science. If you'll join me all now, Dr. Binkley. Come on in. So thank you guys all for joining us. I see you. Great. With so many new faces joining AMR today, why don't we do a round of introductions first, and then you all talk a little bit about your programs and yourselves, and we'll start with you, Dr. Wilcox.
Great. Thank you so much, Kelly, for the excellent introduction, and also just for inviting me on this panel today. We're doing a lot of activities in the Office of Fossil Energy and Carbon Management. Again, my name is Jen Wilcox, and I'm the Acting Assistant Secretary for the Office of Fossil Energy and Carbon Management. And as our secretary mentioned, the majority of hydrogen produced today comes from reforming natural gas, which emits carbon dioxide into the atmosphere. So in our office, we're focused on carbon capture technologies that capture this CO2 and couple it to dedicated storage deep underground. We have an active blue hydrogen project associated with Air Products in Texas today. It's been operating since 2013, and it's been injecting over 6 million tons of CO2 reliably and safely deep underground. And we plan to leverage a lot of what we've learned from the successes of this project for future demonstration and deployment projects associated with blue hydrogen. But we also recognize that today the supply chain of natural gas is not leak tight. And so in our office, we also focus on approaches that mitigate methane leakage from oil and gas industries as we continue to rely on fossil fuels to meet our energy needs. In the instances where leaks are more distributed or difficult to avoid, we're also focused on the conversion of methane to more useful products like hydrogen, but also ammonia. And not only in oil and gas producing regions, but also in regions where there's abandoned or active coal mines that are emitting methane today are also regions that we're interested in. And we're investing in the development of advanced turbine technologies that will ramp up from co-firing with 40% hydrogen today to firing with 100% hydrogen in the future. Finally, we're also interested in areas of improved gasification or reforming of waste feedstocks. These include sustainable biomass waste, waste plastic, or even waste coal. And through gasifying feedstocks coupled to carbon capture and reliable storage, these are also routes to producing clean hydrogen today. Really excited to be on the panel, and I'll pass it off to my colleagues.
Thank you so much. That's really great. And I'm really excited to work with you and really appreciate your continued engagement and collaboration in the hydrogen program across DOE. So let's move next to Dr. Huff from the Office of Nuclear Energy. Take it away.
Hi, so I'm Katie Huff, and until about a month ago, I was a faculty member at the University of Illinois, where in fact I was a recipient of an H2 at Scale award in the group led by Petros Sofranis. Of course, I'm now divested from that as I am the acting assistant secretary here in the Office of NE, but I thought you would all appreciate this connection. Now, carbon-free nuclear power is an absolutely critical part of our decarbonization equation. US reactors currently generate 20% of our electricity and more than half of our carbon-free power in the United States, so we absolutely must find ways to keep them up and running. And all credible reports, including the National Academies, IAEA, and even the Union of Concerned Scientists, indicate that a transition to zero carbon will require preserving the operating nuclear fleet. Most recommend deploying additional nuclear capacity globally, including advanced reactor types. So, with the rise of variable renewables coming onto the grid, the DOE Office of Nuclear Energy is ambitious and excited about hybrid and integrated systems approaches to improve the economics for baseload energy sources like nuclear reactors, and hydrogen is key amongst these. You know, one such opportunity, of course, would utilize nuclear thermal heat from advanced reactors to produce hydrogen, but existing reactors can also benefit from a hydrogen economy by producing hydrogen electrolytically. So as we wait for a future in which very high temperature reactors will be available and capable to make thermochemically generated hydrogen, then we have some demonstration projects in collaboration with EERE and the Fuel Cell Technologies Office to demonstrate the integration in existing nuclear reactors. For some facts, a 1 gigawatt existing nuclear reactor could produce more than 200,000 tons of hydrogen each year. 10 could produce about 2 million tons annually, which is 1/5 of the current hydrogen use in the United States. So there's a really big opportunity here. And this opportunity would allow utilities to produce and sell hydrogen regionally as a commodity, in addition to providing their clean, reliable electricity to the grid. And so DOE NE, in collaboration, obviously, with these other offices, which are key to our success, has awarded millions of dollars through public-private partnerships to utilities that are seeking to build those demonstration scale facilities. And I'll just end by saying, you know, by extending the life of the commercial fleet, we hope to give the industry time to bring new advanced reactors online, which is a major focus of our office right now. And those advanced reactors can reach extraordinarily high heats and could be used to significantly reduce the emissions produced by conventional steam methane reforming processes by replacing that natural gas that is burned to produce the steam. And of course, they can provide essential heat. So ultimately, nuclear energy could support the nation's manufacturing industries through a hydrogen economy across multiple sectors by providing this clean energy. So we really look forward to it.
Thank you, Dr. Huff. It's really cool to see some of the recent nuclear and hydrogen demo projects that we've kicked off and really supporting, again, the overall DOE hydrogen vision. And finally, Dr. Binkley, can you please tell us a little more about the Office of Science and how hydrogen integrates into the work that you're doing?
Okay, thank you. Yeah, and also thank you for the opportunity to participate in the AMR. Office of Science is integrally engaged in the hydrogen shot, and our lead person for this is Dr. Linda Horton, who's our Associate Director of Basic Energy Sciences. I'm going to say a little bit about the Office of Science. Our budget in fiscal year 21 is approximately $7.4 billion, and of that, about $2.5 billion is focused on clean energy and climate research, mostly in the chemical and material sciences, biology, climate modeling, and atmospheric measurements. The Office of Science oversees 10 of the 17 national labs and provides research funding across all 17 national labs. We operate 28 scientific user facilities that host approximately 35,000 scientists per year. The capabilities in the scientific user facilities span chemical and material science, advanced supercomputing, biological and environmental sciences, fusion, energy sciences, and high energy and nuclear physics. We fund researchers, postdocs, and graduate students across more than 300 academic institutions, reaching across all 50 states. And through a series of basic research needs workshops, our office has developed research agendas collaboratively with the applied programs, and we invest in the highest priority areas. With respect to hydrogen, opportunities include breakthroughs for electrolyzers, foundational capabilities, user facilities and tools, systems integration, simulation, prototype measurement facilities, the use of artificial intelligence and machine learning, large data, and so on, novel catalysts, membranes, storage materials, sensors, and so on, as well as process intensification, novel reforming, and gasification technologies. So wrapping up, again, thank you for the opportunity to speak today. We in the Office of Science are really excited about the hydrogen shot, and I'm looking forward to the discussions today. And thanks. I'll turn it back over to you, Kelly.
Thank you. I am always fascinated to hear about the fundamental science that really feeds into applied research and into all of our programs' work. So let's get started. I am sure that everyone is excited and anxious to hear some of the details in Secretary Granholm's hydrogen energy Earthshot announcement. So why don't we start with that? I am curious to get some thoughts on what are the hydrogen priority areas within each of your offices that need to be addressed first to just really start moving that needle on the hydrogen energy Earthshot. Let's start with you, Jen.
Sure, thanks for the great question. So for us, as I mentioned, we have our air products project where we're looking at blue hydrogen. So we are capturing CO2 at that demonstration scale. We're putting it into the earth, which is great. But we need to look at where the other opportunities are, regionally speaking. And so just thinking about the co-location of where we produce hydrogen today, and from our perspective, mostly from natural gas, but also making sure that those projects at the demonstration scale that we choose are co-located with where we can actually put carbon deep in the earth in a dedicated way that doesn't involve more hydrocarbons out of the earth. And so that co-location of capturing CO2 from hydrogen production from natural gas where it's being produced, but also putting the carbon in the ground is really important. And we're also really excited about thinking in that regional way, just like the Secretary mentioned, about focusing on communities that we want to be careful aren't left behind in the transition. So in regions that are just heavy in fossil fuel dependence, so looking specifically at regions like the Gulf Coast, Texas, where there's a lot of natural gas production, and even maybe regions like in Appalachia, like Ohio, West Virginia, and Western Pennsylvania, again, where we can couple to dedicated and reliable storage of CO2. So that regional piece is really important for us in getting the siting right.
Cool. Katie, what about you? Where are you all focusing first to get us going on this Earthshot?
Yeah, our first and most immediate priority is to demonstrate at those existing light water reactor plants the ability to couple directly with some hydrogen energy storage. And as we mentioned, there's a couple projects that are leading the way there, and they are our foremost priority. But we're also hoping that more of those will come behind them, and that we'll have a large scale quantity of hydrogen being produced at some of those existing plants, of which there are 93, 94 nuclear plants operating. There's a lot of opportunity there. And of course, in the longer term future, it'll be advanced reactors with their high temperatures that will become the priority.
Steve, you mentioned in your opening remarks some of the work that you're doing in the Office of the Science, but related specifically to this Earthshot, really getting that needle moved along the way to a new hydrogen economy. Can you tell us what your office is focusing on early?
So, we're really focusing on the long-term front-end research that will ultimately support the goals and objectives of the applied programs. And so, we have energy frontier research centers that have been a part of our core activities over the last many years, where we have small groups essentially funded at levels of somewhere between $2 and $3 million in universities. And so these work in a mode where there's a principal investigator or maybe a principal investigator and co-PI, and then grad students and postdocs that can then be working on topical areas, and one of which will be the science space that is needed for essentially to meet the 111 goals that Secretary Granholm talked about. And so in the near term, there will be funding opportunity announcements for these types of research activities across universities, and then also complementary work in the national laboratories. And I'll stop there.
Yeah, it's just great to be pulling in the colleges and universities and really building that pipeline, no pun intended, of folks to really get into the hydrogen economy. Well, we're all here, all four of our offices on the virtual panel together. And really, I think this is just such a great demonstration of collaboration on the issue of hydrogen. So would love to see what you all think about what are the opportunities for even more collaboration in hydrogen across DOE to accelerate our progress. What are some of the gaps in addition to the cost that we might need to bridge to achieve our goals together faster? We'll start with you first, Katie, this time.
Yeah, I think in order to leverage the extremely high heats, and we're talking about very, very high potential heats, up to 1,000 degrees Celsius, maybe coming out of an advanced reactor technology. In order to leverage that, I think the Office of Nuclear Energy is poised to really make use of innovative thermochemical processes for producing hydrogen. But of course, it's not our area of expertise. So it's a perfect marriage of, different technologies working together. We'd love to see development of those thermochemical properties or processes that could better leverage those very high heats. And we would love to provide those very high heats. So together that could work really well. And I'll just add too that, as Dr. Wilcox mentioned, those very specific regional analyses that are being done in terms of end uses, we're also supporting that kind of work in the Office of NE, and collaboration on that is already started, but I think it should continue so that we can make use of region-specific analyses of the kind of supply chains and industries that we can support.
Cool. How about you, Steve? Where are some areas where we can collaborate even further across all of our offices to help accelerate? Oh, you're on mute.
Yeah. Sorry. One of the areas that we've been investing in heavily over the last couple of years is machine learning and artificial intelligence. And there are lots of applications where machine learning and artificial intelligence can help essentially make processes and run smoother and more efficiently. And so, extending those machine learning, artificial intelligence activities into the type of work that's being done in the Office of Energy Efficiency, Renewable Energy, the Office of Fossil Energy and Carbon Management, and as well as the Office of Nuclear Energy. Another area is to look at systems integration, simulation techniques that have been developed in the Office of Science, I think have potential for use in looking at the systems integration aspects of the new hydrogen Earthshot. I'll stop there.
Cool. Jen.
Yeah, I actually think so. From our perspective, again, our expertise is deep in the carbon capture and dedicated storage piece of things. And from a collaborative perspective, I think an area that would be really exciting to move forward in is looking at the gasification of waste products. And so we talked about plastics, but also biomass, regionally available waste biomass and looking at processes to gasify that. Now, you typically look at a gasification process and you get a syngas, and that syngas is flexible. You can use it for generating electricity. You might have it as a feedstock for a synthetic fuel or a biofuel. But you can actually even push a little bit further in that if you look at that syngas and you do like a water gas shift reaction and convert it to CO2 and hydrogen, you can separate that carbon dioxide. You can inject the CO2 deep underground, and then you have negative hydrogen. And to me, that's really flexible, because then you could actually do something with it, like further down the road. Imagine you couple it to direct air capture of CO2 and have a negative fuel opportunity. And so coupling carbon capture to gasification of waste products like these, there's also a lot of stockpiled tailings associated with the coal mining industry, where that could also be a feedstock for some of these wastes or for some of these gasification processes. So looking at advancing gasification to providing this flexible, syngas that you can either couple to carbon capture or use directly, I think would be a really exciting area. And just FE connecting across the different offices, whether it's BETO and EERE, or it could even be looking at, again, direct air capture, and you've got to have low carbon energy to do that. So maybe that's nuclear, or maybe it's geothermal, but really looking across the different offices to try and get us out of our silos, and leverage all of our expertise to have greater impact.
I was on mute. It's really cool, Jen, how you're looking at what we have existing today and how we can transform that, how we can move that into a cleaner energy future. And I wanted to ask you about the infrastructure. We have a lot of infrastructure for natural gas, the existing infrastructure there. Like, what are some of those opportunities that you've identified to expand the use of clean hydrogen using that existing infrastructure for natural gas?
Sure. So one area is looking at the transport. So how do we develop the infrastructure associated with moving hydrogen around? And so some of the work that we've invested in and looking at is looking at blends of hydrogen with natural gas as a way of moving the hydrogen up to, say, 15%. But one drawback of that is you have to recognize then at the end of the pipeline, you have a separation process if you want to have high purity hydrogen as a feedstock.
Mm-hmm.
So you do have to think about that. But at the same time, we're also investing in turbine technologies where we look at co-firing with natural gas and hydrogen, and ramping up to 100% firing with hydrogen. And even in the interim where we have mixtures, we do have to think about abatement of the carbon, right? So that still needs to be coupled to CCS, which we would further leverage. The other piece is we are excited too about ammonia and the potential that ammonia has. It's a lot cheaper and easier to move ammonia around than it is to move hydrogen around. And so even looking at advanced turbine designs where ammonia is the fuel instead of hydrogen, just as a means to move it, is something that we're excited about. Finally, I'll mention another piece that we're leveraging in our office. Of course, I've already mentioned it a bunch, putting carbon dioxide deep underground. But we also have the potential of using similar formations that we even use, like salt caverns, for instance, that we store strategic petroleum reserves in. We could look at those types of opportunities too, to store large quantities of hydrogen, or even store large quantities of ammonia. And so this is deep in the earth, and that's another way we need to think about getting the amount and the quantities we need to have significant impact, especially if we're wanting to use it for electricity generation at scale. And so those are some of the things that we're excited to leverage.
That's cool. Let's switch over to nuclear and hydrogen. Katie, what are some of the scenarios where we can use hydrogen and nuclear to add value, especially existing power plants, again, using what we already have in play to really clean things up? What do you have any ideas for us?
Absolutely. As we've mentioned, the viability of hydrogen production will be dependent on the region in which it's implemented. So that's why our office is supporting some of these very region-focused market analyses. And we have a few interesting instances, right? For instance, nuclear reactors in Ohio could sell hydrogen to iron and steel manufacturing plants if they are equipped with the new commercial technology for hydrogen-fueled blast furnaces. Meanwhile, states like Illinois and the rest of the Midwest could target hydrogen and ammonia production for fertilizer producers. And there are plenty such reactors in Ohio and the Midwest. At the same time, reactors in California could market hydrogen stations for fuel cell electric vehicles. And so targeting each of those existing plants, which exist in numerous regions around the US, to their regional needs is going to be really essential to building an economic case for those reactors to stay in play when they compete against other sources and strive towards a carbon-free future alongside renewables.
Cool. Steve, some examples from you about, we were talking a little bit about, utilizing what already exists to in a different direction to move to a clean energy economy. What are some of the latest advances that you have in the science office that can help to leverage these existing resources and advance progress in hydrogen?
Well, a couple of ideas there. We've been focusing some of our research on direct air capture of carbon dioxide. And again, the underlying chemical problem there is one of separation science. And so making investments in separation science to see if that technique can be done in a practical fashion. Another one is looking for compounds that can be used in underground sequestration of CO2. So, for example, metal oxide frameworks have been a focus of research for some years recently now. Those are both ideas for that I think are close to where there's practicality. And again, still looking for, even though many of the technologies I think are in hand, then we're still looking for those breakthrough technologies in doing science in those areas. And I'll stop there.
Cool. Steve, I'm going to open up this question to all the panelists, but we'll start with you on this one. It's the last question we have before we need to close down. Given our commitment across all of Department of Energy to diversity, equity, and inclusion, can you give some examples of some of the activities in the Office of Science that incorporates DEI, particularly in the hydrogen space, of course?
Well, I mean, looking not just specifically at hydrogen, but looking across our entire portfolio, diversity, equity, and inclusion have been important elements for us for almost a decade. And so, we have gone through and tried to really understand areas where we need to do better in terms of diversity, equity, and inclusion. Get science into disadvantaged communities. We've also modified our practices and procedures for how we review proposals to make sure that we're doing that in a way that really furthers our diversity, equity, and inclusion goals. We've also, in the national lab space, we have over the last 5 years implemented processes where there are annual diversity, equity, and inclusion plans that are developed in the labs that are then reviewed by panels of experts in the area of DEI. So, it's really more of an effort of weaving it into the fabric of our entire program, which of course then includes hydrogen.
Thank you so much. Katie, how about you in the Office of Nuclear Energy? How are you incorporating DEI?
So a lot of the things that Steve has just mentioned are also happening and being rolled out or have been rolled out in NE. Very similarly, we look at a lot of our processes and we're evaluating where we're weak and trying to grow those places to be stronger. One of our highlights in NE is our university program, where we are able to emphasize awards to minority serving institutions and historically Black colleges. And those collaborations can really build up a broader scope of institutions who are capable of interacting in the nuclear space. In terms of the national laboratories and the research that we're doing, I think those region-focused analyses are certainly part of the approach to ensuring that communities that have new technologies, supported by the Office of NE, those communities are sort of enthusiastically consenting. Where we seek that in all of our projects, and it takes a great deal of effort to work towards that in those communities. And the last thing I'll sort of add is that as we approach this new administration with a focus on environmental and energy justice, the Office of Nuclear Energy is interested in diversifying in terms of topic area and expertise, as well as just, other metrics. And that, I think, we're hoping to see that as we make new hires and focus on a diversification of our thinking and processes so that we can incorporate folks from even the humanities as we consider our approaches to siting and other kinds of activities within the program.
And Jennifer?
It's hard to follow. It's hard to come up with anything different from what Steve and Katie just talked about. We're absolutely trying to just make sure it's woven throughout our funding opportunity announcements as well. That there's consistent language, and also just excited to engage in all the offices so that we're all kind of having that consistent messaging and working together on that effort. One thing that is, we also have a university program in FECM, and we are actually going through an exercise now where we're taking stock in all of the investments that we've made previously and trying to better understand of, just making sure what are we covering in terms of topic areas, certainly hydrogen and other areas, but where can we also, expand resources? And also requested a bit of a bump up too in that program for FY22 so that we can engage a little bit more in that space.
Thank you so much. And thank you to the three of you for joining us today. This has been a really fun conversation. Hydrogen is really so important, such an important element of helping us to achieve the bold goals set by Secretary Granholm and President Biden to tackle this climate crisis so that everybody gets a fair shot at a clean and equitable energy future. I am so looking forward to working with the three of you to accomplish this together. And with that, I will pass it back to Sunita for a comprehensive overview of the hydrogen program at DOE and the work we're doing to support it, as well as the collaborations with other partners, both in the US and globally. Dr. Satyapal, thanks.